Module 6, Lesson 3 deals with one-step subtraction equations. You're going to find this one works a tremendous amount like the one-step addition, only opposite. Content objectives: students will use the addition property of equality to write and solve one-step subtraction equations. Pacing guide suggests this will be a 2-day lesson. Shouldn't take that long, I wouldn't think, but we're going to get into it and find out. Cricket is a popular sport in the Eastern Hemisphere, similar to baseball. The offensive player, the batter, scores for his team or her team by generating runs. The Cricket World Cup is a cricket tournament played every 4 years. Unlike our World Series, which is every 1 year, this is every 4 years, with countries around the world competing to become the world champions. The current record for the most runs scored in a Cricket World Cup is 2,278. Sounds like cricket might be a little more exciting than baseball, because baseball is like watching paint dry. Just my opinion. The next closest batter has 535 fewer runs than the current record holder. Describe some steps you can take to write an equation that can become useful to find the number of runs scored by the next closest batter. These are some of the things we're going to learn how to do in this lesson. Alright, Shrew decided he needs some love, and we're going to do our inquiry question, which says, how can you use a model to write subtraction equations? To get into this one, we're going to say Miles had C trading cards. Remember, C is nothing more than a variable that represents some known number of cards. He has 41 cards left after giving some to his sisters. How many cards did Miles originally have if he gave his sister 17 cards? From here, we're going to take and work on building what we know. What we know is that he has 41 cards left, and we know that he gave 17 cards to his sister. What do we need to find? Well, we need to find out how many cards did Miles originally have. That is the question we're working to solve. They're going to let us use a bar diagram to start playing around with this, where C represents the total number of cards that he originally had. From there, we're going to recognize that he gave 17 cards to his sister, and he gave 41 cards. He had 41 cards remaining, which is also known as the total number of cards minus the 17 he gave to his sister. And that leads us directly to the equation, which you can see highlighted here. C minus 17, this part right here, is equal to 41, this whole part right here. This part right here. So your C value minus your 17 is equal to your 41. And that's all you have to do for this one. They're not asking us to solve the equation, they're just asking us to create the equation. Now it's going to be your turn. Read this problem about Logan going to the mall, come up with your own bar diagram, and see if you can get it done right to come up with a good equation. Did he get it done? The problem states that Logan went to the mall with M dollars. He has $12.67 left after buying a snack. How much money did he originally have if the snack cost $5.33? So we start a bar diagram up, and the total amount he had when he went to the mall was M dollars. We don't know how much M was, though. What we do know is he had $12.67 left, and we also know that he spent $5.33. So the M money he went to minus the $12.67 he had left leaves you with the $5.33 that he spent on the snack. Now, if it was me, I would have done it the other way, but hey, that's all works just fine. Still going to give us the same answer. And for that, you've done everything it's required you to do. You wrote the equation. Did we actually write the equation there? Yeah, you wrote the equation, and therefore you've solved the problem as far as they're concerned. You can write equations to represent real-world problems involving subtraction. And we're going to look at the different cards to see how all this works. First off, in words, describe the mathematics of the problem. Use only the most important words of the problem. This is all like we did when we were dealing with the addition ones. Next, variables. We're going to define the variable. Remember, you have to say what your variable represents. And then finally, you're going to translate all those words and variables into an algebraic equation. It's going to be really simple to do, just like yesterday's was. So to write an equation in a real-world problem, look for key words, and now we're going to take and watch an animation to see how they say we need to do it.
Caroline gave Everly 8 beads and was left with 37 beads. You are asked to write an equation that could be used to determine the total number of beads Caroline had originally. To write an equation for the problem, start by describing the situation. Identify any key words and numbers. You know that Caroline gave away 8 beads and that she is left with 37 beads. Next, use the key information to model the problem with words. Caroline takes away from her total number of beads to give some to Everly. Taking away an amount involves subtraction. So, the total number of beads minus the number Caroline gave away is equal to the number she has left. Now define a variable to represent the unknown number. The number you want to find is the total number of beads, so let the variable t represent the total number. Finally, use the word model to write an equation. The total number of beads is represented by the variable t. Caroline gave away 8 beads, and the number she has left is 37. So, an equation that models the situation is t minus 8 equals 37.
Alright, I think they did a pretty good job on that one, demonstrating how it worked. Let's see what it looks like when we actually start getting into doing the problems. And we're going to start with a story problem that's not exactly true anymore.
The oldest person to travel in space, John Glenn, spent 9 days in space and circled the Earth 134 times. The youngest person to fly in space was only 25 years old and circled the Earth over 17 times back in 1961. At 25 years old, this is 52 years less than John Glenn.
So there's our problem. Now, I said it's not exactly true anymore. That's because John Glenn no longer qualifies as the old. Just a few days ago, William Shatner, who starred as Captain Kirk in the Star Trek series, Star Trek, the original series, he went into space and he was 90 years old when he went up. So that's pretty dang old to be riding a rocket ship. But let's get out of this here and let's actually get into working our problem. So first we need to describe the mathematics of the problem, and we're going to be using words to do this. 52 years less than John Glenn was the oldest person, so less than John Glenn's age is going to be your youngest person's age. Because your youngest person, he's going to be less than John Glenn. Check your answer. That one checks. Now we're going to have to take those values and substitute stuff in. So we're going to let A represent the age of, what do we not know? We don't know what John Glenn's age was, as he was the oldest person. We're going to check that answer. It checks. From there, it's going to be time to write our equation. So John Glenn's age, minus 52 equals the 25-year-old person. Check that. That checks from there. That's going to be the equation we're going to end up actually solving in this problem. From here, we can say the equation can be written as a minus 52 equals 25, or a minus 25 equals 52. Technically, either one is going to be correct. And can you write any addition equations that represent the situation? Yeah, you can, but we're not going to do that today. And with that, we're going to be done with that problem. And once again, it's not asking you to check the work. It's just asking you to write the equation. Okay, now it's your turn. Read the problem about Caroline and her studies, solve it, see if you can get the right answer. The problem says that Caroline studied 1 1/4 hours for her science test. This was a half hour less than how long she studied for her algebra test. So we need to come up with an equation, and we know that if we were to subtract 1/2 an hour, because it's less than, subtract from what? How long she studied for algebra test, then we can find out how long she studied for the algebra test. So they took test minus 1/2 is going to equal to how long she studied for her science. That means A will definitely work, B will not, C will not, and D will not. You only have one correct answer, and we got it right. Easy math. Anybody can do these things. We're going to go ahead and stop the video here, come back to watch part 2, and in part 2 we're going to learn how to solve these subtraction equations.